Guys, today I'm just making a video on some basic insights on how to solve questions related to the topic differentiating from first principles. So this is a very important concept that you guys understand when dealing with maths A levels. So this is just going to be a quick video on how to solve questions related to this concept and how to derive the formula from the graph itself. And if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's start with the video. All right. So here we have to understand is to find a derivative of a function, you need to find its gradient as a function of x. So let's say the derivative of f of x, it could be written as f with an apostrophe on the top of x, or dy over dx. So this is some basic notation that we have to understand. Now you guys can see that I've drawn a graph here. So on the graph is when we get close to the gradient of the tangent, and so the curve at the point x comma f of x, as you guys can see on the graph, that's this point over here, we have to get close to the gradient of the tangent at that point x comma f of x, and this can be done by finding the gradient of the line joining x comma f of x and this point over here, which is going to be x plus h comma f x plus h. Right, that point, and another which is this point, which is closest to that other point at that curve. So on the diagram, the point x plus h comma f of x plus h is just a small distance further along the curve from x comma f of x. Now as h gets smaller, let's say the distance between these 2 points, as it gets smaller, the distance also gets smaller as a result of h being smaller. The closer the points are, the closer the line joining them will be, and the tangent line, between the tangent line. Now there's a really nice formula that I would like you guys to remember for the expression for the gradient of the curve y equals f of x. Now this formula is needed to be understood. So this is f of x equivalent to limit h with an arrow is 0, brackets f of x plus h minus f of x divided by x plus h minus x. Now the denominator can be simplified to h, so you guys can leave it as h as well in the denominator, but just preferably just stay at it as it is. Now the lim, that is also known as the limit. That's the limit as h tends to be equivalent to 0. So now this thing in front of the function, it just means what the function goes towards as h gets towards 0. All right, and remember that a straight line will always have a constant gradient. Okay, now this is the formula that I would like you guys to take down in your notes, since it's very critical that you guys understand this equation and this formula. Now differentiation from first principles, it just uses the definition of the derivative of a function of f of x. That's all it is. And this formula is just similar to the gradient formula of y2 minus y1 divided by x2 minus x1. It's just another notation. We're just taking the gradient of 2 points. That's all. Now let's move on to a question example so we can understand. Now the question states, to find an expression for the gradient of the function f of x is equivalent to x raised to the power 2 by differentiating from first principles. So we can see here f of x, we have to first write down the formula. That's very important for differentiating from first principles in order to score those marks. And then after you do that, what you're going to do is you're going to switch in the values. You're going to use this value here, f of x is equivalent to x raised to the power 2. All right, and we're going to replace it with your values for both f of x, and you're going to replace it into this equation. So we have to understand this, how this works. So we're going to write f of x is going to be equivalent to lim. By the way, do write lim h, the limit, as h tends to be 0. Do write it in all the cases when dealing with this. I'm going to put it in brackets, and it's going to be h plus x, x plus h. That's going to be squared. This is the reason why we're squaring this, is because f of x, whatever value is in f of x, that is x plus h, x has to be squared. So that's why we're squaring the value in this case, minus x squared, since we know f of x is going to be equivalent to x squared. So that's why we are substituting the values accordingly. Divided by x plus h minus x. This just simplifies, like I said, it just simplifies to a h. All right. Okay. Now, once you do that, once you simplify it, you just multiply out and simplify. Now you have to decide what will happen as h gets close to 0. That is after you open up the brackets. So we're going to open up the brackets. In this case, we're going to write down all the steps. So this is just basic algebra, wherever you have to open up the brackets. In this case, I'm just going to be opening up the brackets. So we're going to get a value of about, by the way, do practice on writing down these steps. It's very critical. So it's going to be x squared plus h of x, hx plus h squared minus x squared, h squared divided by h. This is going to cancel out, and you're going to get your value f of x equivalent to lim. Just multiply and simplify. That's the first step that you guys have to do. So it's going to be 2hx plus h squared divided by h. This is going to be your simplified value. Now, once you do that, is you're going to factorize this top part since we want to get rid of the denominator. So we're just going to keep writing that down. Okay. So you're going to make h outside 2x plus h divided by, sorry, not 2, h. Cancel out h's, it becomes 1. And you're going to write down your simplified version of this. So we're just proving using differentiation from first principles. So you're going to get a value of about 2x plus h. Now, after we have multiplied out and simplified, now is when we have to decide when h gets close to 0. So what we mean by is we're going to write down as h is going to be closer to 0. We're going to substitute the value of h. In that case, you're going to get f of x. That's going to be equivalent to lim h arrow, put the arrow, and you're going to have, actually you're going to do this separately. As h is equivalent to 0, you're going to put a comma. 2x plus h is going to be equivalent to 2x plus 0, which is going to be 2x itself. So that's just going to be a value. And then your final statement must be f of x, which is going to be equivalent to the limit as h tends to be 0. I'm going to write 2x plus h, which is going to be equivalent to 2x. Therefore, the derivative of x squared is 2x. We have just proved that using the formula. Whereas this is, some people say that we can directly find out 2x just by differentiating x raised to the power 2. I know that you can do 2x all raised to the power 2 minus 1. That becomes 2x directly. So why go through the process of doing all of the steps? You're just doing it for the exam. That's all. You just, in case if the question asks you to prove using differentiating from first principles, you got to show all these steps. It's just to score those marks. That's all. But I would say directly you can solve differentiation. This is just a proving method when the questions just ask you to differentiate using first principles. That's the reason why you guys have to learn this concept for A-level maths exam. This seems to be the end of the video. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. New content will be posted soon, and do comment below on what your thoughts are about this video. And yeah, I think that's it. All right, bye guys.